Hi, this is Daniel Green. I'm making a short video for the MakerCore application. I thought I'd run through some of the things I'm doing locally, um, and I'm pulling up some slides that are a little old, but I thought I'd just make a quick video to tell you a little bit about myself and about our computer club and maker activities in the local area. So I'm currently with the Oracle Corporation. I'm a senior systems engineer in the Java group. These slides are a little old. Oracle acquired Sun Microsystems, and these things happen. One of the things that I reach out on the weekends, on the evenings, is we teach computer club around town, different schools and workshops, and basically we try to get kids making things and not so much computer application training about Word and Office and stuff, but getting into the actual computer science, making a video game portions that involve math, but in a fun way. So just a little bit about myself. There's a picture of me on the right next to some fish in Seattle, and there's my cartoon version with my Java gear on. I play a lot of video games when I was a kid, and it was a lot of fun, and my kids are 13 and 15, and they play a lot of video games. And our computer club sort of came out of coaching First Lego League for 5 years, and a lot of the students wanted to continue doing the software portion of the software-hardware combo where they were creating applications or creating robots for the competition for First Lego League. And the interesting thing here is a lot of what students do are sort of, we call them digital natives. A lot of what they end up doing is texting and playing video games. They're consuming, but they're not creating so much. So I'm really trying to focus on getting them creating things that have either just a software component or a software and a hardware component. First Lego League is a good example of that. This is a graph that I've extended to get the students' attention that if nobody's making video games and there's none to play, so that's my little joke on the students and in general how things are going. That graph's actually a little better in the recent years, but that's the trend. And so one of the things I emphasize to the students is, look, that stuff that you like, that phone, that video game, that Wii U, whatever it is, people had to make that, and there's a lot of math involved and a lot of cool stuff. But if you don't get into the mode of making this yourself, you're going to be a society of consumers, and that's not going to be so great. So I call this being subversive. We actually go and pick up free software tools to make their own video games. And MIT refers to this as the digital clubhouse or the computer clubhouse, and that's sort of what I do. Here's an example. I'll go through this really quickly in Scratch. Scratch is a freely available tool from MIT. I participated in the Maker Faire Bay Area booth. In the Oracle booth, we had Scratch and Greenfoot and Alice up, and in the Kansas City Maker Faire as well, we had a booth so the students could try all these things. But the general point is, let's go make something that's fun and that involves math, but in a way that isn't a standardized test. So to give them an example, we start off with a quick game in case some of these kids, haven't played Asteroids. Asteroids is sort of an old game, so we go through and make sure they're familiar with Asteroids as an example. It has, X and Y coordinates and momentum and projectiles and all this stuff. So then we go and make our own. So we start off with typically Scratch from MIT, and here down below are the computer programming concepts I want them to pick up as we progress through and do something like eventually make a Minecraft mod in Java. This is not the place to start in Java without an IDE, without drag and drop blocks if the kids are 9. I've even had kids as young as 4 and 5 make great Scratch projects, but they don't type code, they drag blocks together, and it's a lot like making your own game by playing a game. It's rather cool. So as an example, using Scratch as one of the tools we use in Computer Club, we break the game up in the following way. We break it up into moving and what happens when you go off screen, what happens when you run into something, what happens when you shoot, and then dealing with momentum. So I won't go through this in detail, but in general, here are the steps that we sort of lead them through and let them customize their own game. So it involves a rocket sprite ship, and here are some scripts that they put together so the thing will move around. It has different appearances, whether it's got rocket thrusting out the back or exploding, and it's got some sounds involved with that. We have to deal with off-screen, which is the part I'm starting to get interested in, so that they have to deal with conditional logic. And I phrase this as, you have to have the rocket ship ask itself questions, whether it's off the screen, what's its position, and you have to deal with X and Y appropriately in order to maneuver that thing off the screen and back on the other side. When we get to collisions, we introduce sort of a state in variables, so that there's a simple variable that's Boolean, which is either crashed and it's 0 or 1, and based on tests on whether they're in the same space as the other objects, it crashes or not. So this is just an example. We introduce moving randomly so that the asteroids fly around the screen, or they might be zombies or something else in another game. This is all stuff I put together for my local computer club. And then we have game over, end state, whether the thing is blown up or they've shot all the asteroids, etc. A lot of the young men want to shoot everything, so we incorporate shooting with projectiles in there, and it's actually kind of fun because shooting in this case is simply another object on the screen, which we have to deal with in terms of position. We have to get the X and Y position of the ship and the speed and the rotation, and make it look like the projectile suddenly appears shooting out of the ship. There's a lot of math involved in that, but they're making a video game, so they don't complain too much. Here's a way to get multiple smaller asteroids as you shoot the asteroids and so forth. So it just kind of gives you an idea. And one of the things I'm interested in is when we get through some actually fairly complicated math stuff in order to get momentum working, so that when you let off the gas, the ship continues to fly through space. So we do a little bit of trigonometry, and we have things in Scratch to do sine and cosine. So we go through a little bit of conceptual material, even if they haven't had trigonometry yet. We also have to deal with coordinate systems. The trig functions require, or rather we expect a certain coordinate system, so we have to adjust the coordinate system between what's on the screen and what the functions that we're dealing with are. And so we put together something that looks a lot like this in terms of moving. And the interesting part is we can turn around and do the exact same thing in a tool like Greenfoot using Java. And most of these students I work with are all playing Minecraft, and they're aware that if they know Java, they can make a mod in Minecraft. This is of high interest to almost every student I've worked with. So we go through this similar process and show the visuals for what we did in Scratch to do video games, and then we move it over and say this is what the Java code looks like for that. So same kind of thing, we have to adjust the coordinates accordingly in Greenfoot, and so we basically go through what it takes to code in Greenfoot the game we just did in Scratch. So we basically moved from drag and drop programming into typing, and I would probably typically have kids 12 or above do this, whereas the Scratch is typically okay for students 4 to 5 and up. So similar kind of thing, we have to motivate, getting the thing moving around and building momentum. So that's just a kind of an example of moving into doing some coding portion of this from drag and drop blocks. And this is usually a follow-on from making a robot move in NXTG for First LEGO League, things like that. So I just thought I'd go through some of my slides that I typically use in my workshops as an example of creating their own video game. So it gets pretty involved, and we usually take a couple of hours to make a game, maybe over a couple of weeks. So that's interesting, and so we kind of go through some of the pieces to finish off the game in Java, and that's fine. And what I wanted to get to here is a lot of what we do in Computer Club I think applies directly to Maker Faire. At Maker Faire Bay Area, we had Greenfoot and Alice and Java set up, and it was like 24/7 kids wanting to get in the Kinect camera and play with stuff. So it was great. Very interested in making their own video games. And the thing I really like is, even for young kids, we can get this drag and drop metaphor moved into making their own game in a way that they might end up doing something like Minecraft. So a lot of the kids like to play Minecraft, but there is a component of that which is they can make their own Lego block, make their own piece of Minecraft using Java, which we get into using Greenfoot. And that's of high interest, but everybody wants to start with Minecraft, and that's not exactly, no, it's not a drag and drop environment at all. So rather than type a bunch of code into an IDE, we start with Scratch and Greenfoot first, so that we go through and sort of get them familiar with some of the computer programming concepts, and then talk about Minecraft. So there's a Minecraft EDU version of Minecraft, which I'm interested in setting up in a classroom. So these are just some of the things that we are doing with Computer Club here locally, and we've got workshops set up through the local science store for robot programming, which is a lot of fun, and then I also work with Science City and Union Station in Kansas City to do some of these things as well. So that's a quick overview of some of the things that we've done locally with our Computer Club in Kansas City, working with different high schools and workshops for students in conjunction with the local science store, the local Make KC group, and Science City and Union Station. I'll go ahead and submit this video in for the MakerCore application. Thank you.